Hi students, welcome to chemistry classes. In previous class, we learned about the nitrogen compound, that is ammonia, means preparation of ammonia and physical and chemical properties of ammonia and the structure of ammonia and the uses of ammonia. And students, in this class, we are going to learn with the next compound of nitrogen, that is nitric acid, HNO3. Next compound, that is HNO3. Nitric acid means preparation of nitric acid like laboratory preparation as well as large scale preparation, and properties of nitric acid, that is physical properties of nitric acid and chemical properties of nitric acid, and uses of nitric acid and the structure of nitric acid. Okay, let us start with the first one. Nitric acid is very important for your theory annual examinations. First of all, students, nitric acid. Here, nitrogen forms different oxoacids. Nitrogen forms different oxoacids. Nitrogen forms different oxoacids such as H2N2O2. H2N2O2 and HNO2 and HNO3 and HNO4. So these all are oxyacids of nitrogen. H2N2O2, hyponitrous acid, and HNO2, nitrous acid. HNO2, nitrous acid, and third one HNO3, nitric acid, and last one HNO4, that is pyronitric acid. Hyponitrous acid, nitrous acid, and nitric acid, and last one is pyronitric acid. Okay, students, or you can say peroxynitric acid. So among them H2N2O2, HNO2, HNO3 and HNO4. HNO3, nitric acid, is very important. Okay, due to its property and due to its structure and due to its uses, HNO3 is a very important compound. Okay, student, here first one, preparation of nitric acid. Preparation of nitric acid. In that, first one, laboratory preparation of a nitric acid. In that, first one, laboratory preparation of nitric acid. Laboratory preparation of nitric acid. Here, student, nitric acid can be formed by the reaction of sodium nitrate and H2SO4, and you will get a nitric acid. In laboratory preparation, nitric acid can be formed. Nitric acid can be formed by the reaction of NaNO3 and H2SO4. Student, here nitric acid can be formed by the reaction of NaNO3 and H2SO4. Okay, according to this reaction, we can write the reaction here. According to this statement, we can write the reaction. Nitric acid can be formed. Okay, HNO3 can be formed by the reaction of NaNO3 and H2SO4. I will write the reactants as a NaNO3 and H2SO4, sulfuric acid. Okay, it will combine to form a HNO3. Here H and NO3, it forms a HNO3, and what is the remaining, students? NaHSO4. That is the byproduct. NaHSO4. This is nitric acid. This is nitric acid and this is sodium hydrogen phosphate. Sorry, sulfate. Sodium hydrogen sulfate. Sodium hydrogen sulfate. So this is the laboratory preparation of a nitric acid. Student, sodium nitrate plus H2SO4 combines to form a nitric acid and a byproduct is sodium hydrogen sulfate. Okay. And the next one, on large scale preparation. On large scale preparation. On large scale preparation. On large scale preparation. On large scale preparation, HNO3 can be manufactured by the process that is called a Ostwald process. That is called a Ostwald process. This is important for your annual examination. On large scale preparation, HNO3 can be formed by Ostwald process. Okay, let us start with that. You can take it down. Okay, next one. Manufacture of nitric acid by Ostwald process. Important. 3 or 4 marks question. Manufacture of nitric acid by Ostwald process. By Ostwald's process. Here, student, HNO3 can be formed by the catalytic oxidation of ammonia. Okay, students, HNO3 can be formed by the catalytic oxidation of ammonia, and the process of formation of nitric acid from the catalytic oxidation of ammonia is called the Ostwald process. I will write here the process of formation of nitric acid. The process of formation of nitric acid by the catalytic oxidation of ammonia. By the catalytic oxidation of ammonia. And the process of formation of nitric acid by the catalytic oxidation of ammonia is called Ostwald process. Is called Ostwald process of formation of ammonia. Okay, students, simple. The process of formation of nitric acid by the catalytic oxidation of ammonia is called the Ostwald process. Here, there are 3 important steps. Mainly, in step 1, manufacture HNO3 by Ostwald process. It has 3 steps. In that first step, that is step 1. Step 1, oxidation of ammonia. Oxidation of ammonia to form nitric oxide. Okay, oxidation of ammonia, it forms a nitric oxide, that is yellow. So here the reaction, ammonia 4NH3 plus oxidation of ammonia means we should provide a oxygen 5O2. 4NH3, that is ammonia, 5O2, this is oxygen molecules, which is forms of nitric oxide in the presence of platinum catalyst or rhodium catalyst at 500 Kelvin temperature. It gives 4NO, that is nitric oxide. Nitric oxide plus remaining 6H2O is water molecule is remaining in the reaction. Ammonia react with oxygen. There is a catalytic oxidation of ammonia takes place in the presence of platinum catalyst at a 500 Kelvin temperature. Nitric oxide will be formed. Okay. In a second step, what is the second step, students? Here, simple. In second step, that is oxidation of oxidation of nitric oxide to nitrogen dioxide. Simple, student. This is second step. Step number 2, oxidation of nitric oxide to nitrogen dioxide. Okay, I will write the reaction here. NO, nitric oxide, 2NO plus oxidation means in the presence of air, O2, below 100 Kelvin temperature, or you can say below 100 degrees Celsius temperature. Below 100 degrees Celsius temperature, you will get a nitrogen dioxide, that is 2NO2. Nitrogen dioxide. This is the second step. Nitric oxide is formed in the first step, that is oxidized with the help of oxygen below 100 degrees Celsius temperature, means low temperature. You will get a dinitrogen. And the third step in the Ostwald process, that is formation of nitric acid. Formation of nitric acid from NO2, from nitrogen dioxide, from NO2. Here, students, reaction 3NO2 plus H2O. 3NO2 plus H2O, and you will get the product 3NO2 plus H2O, 2HNO3. This is the formation of nitric acid. Simple, students. Ostwald process means the process of formation of nitric acid by the catalytic oxidation of ammonia. It is called the Ostwald process. Here 3 steps are there. In the first step, oxidation of ammonia takes place. In second step, oxidation of nitric oxide takes place, and in third step, nitrogen dioxide react with the water molecule. It forms a nitric acid, HNO3. Okay, take it down. Next one, physical properties of nitric acid. Physical properties of nitric acid. Okay, there are some physical properties are there. I'll write here. First one, it is colorless liquid. It is colorless liquid when it is pure. It is colorless liquid when it is pure. And it is yellow in color. It is yellow in color when impure. Student, here nitric acid, it is actually colorless liquid, but it becomes a yellow color when it's become impure. So yellow color is due to the dissolve of nitrogen dioxide. If nitrogen dioxide present in the HNO3 or dissolved in the HNO3, it becomes a yellow in color. Means we can say it's an impurity. Nitrogen dioxide is a impurity. Okay, due to that impurity, it's become yellow in color. But actually, when it is pure, it is a colorless liquid. And second point, students, it has a specific gravity. Nitric acid, it has a specific gravity. That is 1.504 gram per cm cube. It has a specific gravity, that is 1.504 gram per cm cube. It is the specific gravity of a nitric acid. And next one, freezing point. Freezing point of nitric acid is 231 Kelvin. 231 Kelvin, and boiling point of nitric acid, is 355 Kelvin. 355 Kelvin. Okay. Freezing point 231 Kelvin, boiling point 355 Kelvin. So this is about the physical property of nitric acid. And next one, chemical properties of nitric acid. And before going to that, I will draw a structure of nitric acid. Okay. First one, structure of nitric acid. Structure of nitric acid. Okay. In the structure of nitric acid, bond angle and bond length is important. Structure of nitric acid is like this: hydrogen, oxygen, nitrogen, and oxygen and oxygen. This is the structure of nitric acid. Here, bond length between oxygen and hydrogen is 96 picometer, and bond length between oxygen and nitrogen is 140 picometer. And here bond angle, this is the bond angle is 102 degree, and here bond angle is 130 degree. Okay. This is the structure of nitric acid. And the next one, chemical properties of nitric acid. So take it. Okay students, next one, chemical properties of nitric acid. Chemical properties of nitric acid. In that first one, acidic nature of nitric acid. Here student, nitric acid, it acts as a strong acid in aqueous medium, like this. HNO3, when it reacts with aqueous medium, means water. HNO3 plus H2O, it gives rise to hydronium ion. H3O plus hydronium ion, and nitrate ion will be formed during the reaction. Okay, this is hydronium ion. During the reaction, when nitric acid reacts in aqueous medium, it acts as a strong acid. Means it produces H3O plus hydronium ion. Okay, that's why it is called a strong acid. And next one, oxidizing nature. So here HNO3, it acts as an oxidizing agent. Here the reaction for oxidizing nature, that is 2HNO3. 2HNO3, when it dissociate or decompose, it gives rise to 2NO2 plus H2O, and it gives nascent oxygen. It gives nascent oxygen. 2NO2 and H2O and oxygen. 2 plus 3, okay, 4, 5, 6, okay. 2NO2 plus H2O, it gives a nascent oxygen. Okay, this is this reaction shows the oxidizing nature of nitric acid. And next one, reaction with the metal. When nitric acid is react with a metal like copper and zinc, it produces different compounds. For example, we can say nitric acid, it reacts with all the metals except gold and platinum, because gold and platinum are noble metals. That is why it do not react with gold and platinum. Yes, HNO3 did not react with the gold and platinum. Okay. Here HNO3 reacts with the copper, it gives rise to a product, that is a complex product 3CuNO3 twice, and nitric oxide will be formed. And the second one, when action with the zinc, HNO3 react with the zinc, it forms a complex, that is 4ZnNO3 twice, and water molecule, and here dinitrogen monoxide will be formed. And third one, brown ring test. So here student, brown ring test, it is usually used for to detect the nitrate ion. Brown ring test, it is usually used for detection of nitrate ion in a particular solution. Detection of nitrate ion. Detection of nitrate ion. In the detection of nitrate ion, brown ring test will be used. So here brown ring test is simple test, like it is For example, FeSO4 solution added to the solution which containing nitrate ion. Nitrate solution means this nitrate solution containing the nitrate ion. For this solution, FeSO4 should be added, and slightly along the sides of the test tube, concentrated H2SO4 should be added. Okay, along the sides of the test tube, H2SO4 is adding to the nitrate solution in the test tube. Means this test tube containing a nitrate solution as well as a FeSO4 solution. Along the sides of the test tube, H2SO4, when you add H2SO4, there will be a formation of a ring. That ring is called a brown ring. Means it is brown in color. So it forms the ring in the interface between a nitrate solution and a H2SO4 solution. It indicates that the solution which containing a nitrate ion. Okay, student, I will write the reaction here. Brown ring test reaction. First one, nitrate. NO3 minus plus 3Fe2 plus. NO3 minus 3Fe2 plus 4H plus. Here, iron is reduced nitrate to nitric oxide. Iron is reduced nitrate to nitric oxide. The product is nitric oxide and 3Fe3 plus, and remaining is H2O. Remaining is H2O, that is 2H2O. This is a balanced reaction. And next one, this Fe complex means iron complex. It forms a brown ring. That is, I will write here. Okay, Fe H2O 6 times. FeH2O 6 times. This is the complex. When it react with the nitric oxide, it forms a brown colored complex. It forms a brown colored complex, that is FeH2O 5 times. FeH2O 5 times NO. This is the complex 2 plus, and remaining is H2O molecule. Okay, I will write it. The last reaction I will write here. Just taking this one. Brown ring test. Last reaction. FeH2O 6 times. This is a complex. When it reacts with the nitric oxide, it forms a brown colored complex, that is FeH2O 5 times and NO 2 plus and water. This is the brown color. And students, next one, uses of nitric acid. Uses of nitric acid. Student, nitric acid can be used as a used in the manufacturing of ammonium nitrate, which is present in the fertilizers. Means we can simply say nitric acid used in the manufacturing of fertilizers. And next one, nitric acid is used in the explosives like TNT and gun cottons. Nitric acid is used in the preparation of explosive like TNT and gun cotton, as well as it is used as a oxidizer in a rocket fuel. So these are the uses of nitric acid. Okay, students. Chemical property, oxidizing nature as well as acidic in nature, reaction with the metal, and reaction with copper and zinc, and brown ring test. This brown ring test is used for the detection of nitrate ion, which is present in the solution. And last one, uses. In the uses, nitric acid is used in the manufacturing of ammonium nitrate, which is used in the fertilizers, and nitric acid it is used in the explosive like TNT and gun cotton. And next one, it is used as an oxidizer in a rocket fuel. So this is about nitric acid preparation and physical and chemical properties and uses and structure of nitric